Okay, so today we're going deep on something pretty wild.
Yeah.
It's called Mathematicus Universal.
Mm.
And it's not just about like math, numbers equations.
Right.
This is saying that like existence itself
Yeah.
is like mathematical.
Interesting.
It's all transformations and connections and like this
A fundamental unity.
fundamental unity.
Yeah,
Yeah.
yeah.
So
So for everyone listening,
yeah. Yeah.
what's really cool here is that it kind of like turns things upside down.
Yeah.
Instead of thinking of math as just our tool to understand the universe, right?
Like a language that we use
Yeah,
to
exactly.
describe it
Mathematicus Universal says, no, no, no. The universe itself
is the math.
is fundamentally mathematical.
Whoa.
It's saying everything
That's trippy.
from like the tiniest particle to the
Yeah.
biggest galaxy.
Yeah.
It's all part of this like mathematical dance
Of change.
of change and interconnectedness.
I like that.
Yeah.
I like that a lot.
It's a cool idea.
Okay, so we've got the source material here,
Right.
and we're going to try to break down some of these core concepts of Mathematicus Universal.
Yeah.
We're talking about matter never really disappearing.
Mm-hmm.
We're going to look at gravity and light in a whole new way.
Totally different way of thinking about
That even like basic math
rethinking the fundamentals.
gets a total makeover.
Yeah.
So our goal here is to try to like,
Break it down.
break it down, make it clear,
Yeah. Make it understandable.
and hopefully spark some like whoa moments.
Some aha moments for sure.
About the universe.
About the cosmos.
Yeah.
And your place in it.
Yeah. All right, so let's jump in.
Let's do it.
Let's start with this idea that like matter never truly disappears.
Okay, so this is a big one.
Yeah.
This is a key principle in Mathematicus Universal.
Right.
The source really emphasizes this idea that matter,
It's not like
it's not created out of nothing, right? It doesn't just appear and it doesn't get destroyed into nothingness.
Right.
It's constantly transforming.
it's changing.
Yeah, shifting
Okay.
between different forms and different energy states.
So like give us an example. This is something we can
Sure, yeah.
wrap our heads around.
Think about a burning candle.
Okay.
The wax seems to vanish, right?
Yeah, it melts away.
It melts away.
Gone.
But it's not actually gone.
Okay.
It's transformed.
So it's become big.
It's become heat. It's become light.
Yeah.
And it's become other substances that are released into the air.
Oh, interesting.
So the universe isn't really about things just vanishing.
It's not about things disappearing.
It's more like this constant,
It's more like a dance.
yeah, a cosmic ballet.
I like that.
A cosmic ballet of transformation.
Yeah, and that implies connection then, right?
Yeah, absolutely. It implies this fundamental interconnectedness
That we don't always think about.
we don't often consider.
No, we don't.
Yeah, it's kind of mind-blowing when you start to think about it.
So this cosmic ballet,
Yeah.
this isn't just like everyday stuff. Like candles, it's happening on
A
like a
grand scale.
huge scale.
Absolutely. It applies to the biggest, most dramatic events in the universe.
Right.
Like how stars are born,
Oh, yeah.
from these massive clouds of gas and dust.
Huge.
A huge cloud.
And then they burn for billions of years.
And they shine for billions of years.
Yeah.
Fusing hydrogen into helium,
Like releasing all this energy.
releasing incredible amounts of energy.
Yeah.
And then when they reach the end of their lives,
Yeah.
some of them explode
Supernovas.
as supernovas.
Yeah.
And they scatter their elements across space.
Like seeding the universe.
Yeah, it's like planting the seeds for new stars and planets.
Right.
And what Mathematicus Universal suggests
Yeah.
is that even these huge, seemingly chaotic events,
They're not random
they're not random, they're governed by
by mathematical principles.
orderly mathematical principles.
So there's order even in the chaos
It hints at a deep structure
underlying everything.
underlying everything we see.
That's pretty profound.
It's a pretty amazing idea.
Okay, so it's not about things disappearing.
Right.
It's about them changing,
Transforming
connecting to other things.
and constantly interacting.
Yeah, so everything has a history
Yeah, you could say that,
embedded in it.
that everything carries a history with it.
Cool. Okay, let's
Look.
talk about gravity now.
Okay.
So we all feel it,
Yeah.
but Mathematicus Universal has a very specific idea
Yeah.
of what gravity actually is.
Right. It's not just that invisible force pulling us down
Yeah.
like we traditionally think of it.
Okay, so what is it?
So the source explains gravity,
Yeah.
not as a force that reaches across empty space,
Okay.
but as the direct consequence of the curvature of space-time.
Okay. Can you unpack that a little?
Sure.
What does that mean?
So they use this classic analogy
Okay.
of a bowling ball placed on a trampoline.
Okay. I've seen that.
Right.
Yeah.
So you imagine the heavy bowling ball.
It makes a dip?
It creates a dip. Yeah, a curve in the surface of the trampoline.
Right.
Now, if you roll a marble nearby,
Yeah.
what happens?
It rolls toward the bowling ball.
Exactly.
Yeah.
The marble rolls towards the bowling ball.
Right.
Not because the bowling ball is like reaching out and pulling it,
Yeah.
but because the marble is following
The curve.
the curve in the trampoline.
Right. So it's the shape of the trampoline.
That's guiding the marble.
That's dictating the movement.
Exactly.
Yeah.
So in the same way,
Huh.
massive objects,
Stars, planets.
stars, planets, galaxies,
Yeah.
they warp the fabric of space and time around them.
They make a dip in space-time.
You can think of it that way. Yeah.
Okay.
And that warping that curvature,
That's what we feel as gravity.
that's what we experience as gravity.
Oh.
And the more massive the object,
The bigger the warp?
the bigger the warp, the stronger the gravitational pull.
Okay, so it's not a tug-of-war.
Right. It's not about forces acting at a distance.
It's about following the contours of space-time itself.
Yep. Exactly. It's a more geometric understanding of gravity.
Okay, and that curvature,
Mm-hmm.
that's what explains why planets orbit stars.
Precisely. The planets are essentially following these curved paths created by the star's mass.
Right.
And Mathematica Universal suggests that it can provide the mathematical tools.
The equations.
Yeah, the
To
equations.
describe all this.
To describe and even predict these cosmic interactions.
With accuracy.
With incredible accuracy, yeah.
So like from planetary orbits?
Yeah, from the precise paths of planets
To like galaxies evolving.
to the large-scale evolution of galaxies.
Wow.
Yeah, it's a powerful idea.
Okay, so this brings us to what the source calls the
The first universal principle,
the first universal principle.
which is all about the relationship between matter and gravity.
Yeah, and this sounds like a really big deal.
This is like the core.
The heart of it.
Yeah, the heart of Mathematica Universal.
Okay, so tell us about this principle.
All right, so the source says
Yeah.
that the existence of gravity is totally dependent on the existence of matter.
Okay.
You can't have one without the other.
So they're like inseparable.
Yeah, they're a package deal.
Like two sides of the same coin.
Exactly.
Okay.
And they describe matter and gravity
As
like
the most fundamental thing
fundamental, indestructible properties
from the very beginning.
that have existed from the very beginning of the universe.
Oh, wow. Okay, so they're like inseparable twins
You could say that. Yeah.
that always exist together.
Yeah, always together from the get-go.
Okay, so how does that work?
All right, so the source explains it like this.
Yeah.
Matter distorts the space around it.
Okay.
And that distortion, that's gravity.
That's gravity.
And the strength of that gravitational effect
Yeah.
depends on how much matter you have.
So the more matter.
The more matter, the stronger the gravity.
Okay.
And then gravity, in turn, acts on matter, attracting it.
Pulling it in.
Yeah, pulling it in. And that makes the curvature of the universe even more pronounced.
Goes like a feedback loop.
Yeah, it's a self-sustaining, interconnected system.
Matter creates gravity.
Yeah,
Gravity pulls in matter.
which creates more gravity.
And so on.
Exactly.
Okay. And things get even more interesting
Yeah.
when you start talking about what happens when a lot of matter gets together.
Right, when you have a lot of matter concentrated in one place.
Yeah, like in a star.
Exactly, like in a star. So what happens then?
Well, the gravity from all that matter,
Yeah,
it starts to compress it.
it squeezes it together.
It squeezes it really, really hard.
Yeah.
And that creates heat.
From the pressure.
Yeah, from the immense pressure.
Yeah.
And if there's enough matter, that heat gets so intense
Yeah.
that the matter transforms into a liquid state.
Oh, wow.
And that intense heat
Yeah.
that's expressed as light.
So light is like a byproduct of this
Yeah, you could think of it that way.
squeezing of matter.
Of this intense gravitational squeezing.
Okay, so light isn't like a separate thing,
Right.
just floating around. It's not like little particles just flying through space.
It's part of this whole
It's a manifestation of this process.
of gravity and matter interacting.
Exactly.
Okay.
That's so cool.
It's a pretty amazing idea.
All right, so now we've got matter.
Mm-hmm.
We've got gravity.
Yeah.
We've got light,
Right.
all kind of connected.
All interconnected.
What about the paths that they take?
Okay.
Like when gravity's acting on them?
So the source makes an interesting distinction here.
Okay.
They say that if matter manages to escape,
From like a star's gravity?
yeah, if it gets ejected from a star's gravitational pull,
Okay.
it'll still tend to travel in a circular path.
Even though it got flung out.
Yeah, even though it's been thrown out.
Why?
Because it still has its own gravity,
Oh,
however small.
right.
And that causes it to follow a curve.
Its own little curve.
Yeah, its own little curve in space-time.
Okay.
Light, on the other hand,
Yeah.
travels in a straight line,
Oh, interesting.
essentially taking the shortest path.
Along these pre-existing gravitational distortions.
Okay, so matter curves.
Matter curves,
Well, light goes straight.
light goes straight.
Unless it's bent by something really massive.
Right, exactly.
Okay, so this whole idea of matter being
Mhm.
indestructible,
Yeah,
constantly moving along these curves,
right.
created by its own gravity.
Yeah,
This is why
this is why.
Mathematicus Universal says that you can't really subtract.
Exactly. Traditional subtraction doesn't really work in this framework.
It doesn't make sense.
It doesn't make sense because matter and gravity are fundamental.
Yeah,
They're indestructible.
right.
So the idea of actually subtracting them
But destroying them,
and making them disappear,
yeah, making them vanish into nothing,
oof,
that doesn't fit.
it doesn't compute.
It doesn't compute.
Okay.
So the source says
Yeah.
that the way we usually use subtraction
Like to say that something's gone?
to represent something disappearing,
Yeah.
that's more of a description.
It's not the fundamental truth.
Yeah.
It's not a fundamental truth. It's a subjective way of looking at things.
Okay, so if matter never really disappears,
Right.
then subtraction just doesn't.
Needs a rethink.
Yeah, it needs a total makeover.
Yeah.
Okay, so if we can't subtract,
Mm-hmm.
how does Mathematicus Universal explain change?
Okay, so this is where it gets really interesting.
Yeah,
They introduced this concept called this simulator.
the simulator.
Yeah, and it's a mathematical way
Right.
to explain how matter changes
Okay,
without it just disappearing.
right.
So instead of things vanishing,
Yeah,
we're talking about transformation.
things changing form?
Yeah, changing form, changing state,
Okay,
but still existing.
still there.
Still there, just in a different way.
Okay, I'm following you.
Okay, good.
So how does the simulator work?
All right, so it uses a universal language,
Okay.
and it all starts with the number 1,
One.
which represents like an initial state.
Okay, the starting point
Yeah, the starting point
of something.
of something. And then there's a sequence,
Okay.
a standard universal sequence of transformations.
Okay.
So you start with 1, and then it goes 1, 2, 3, and so on.
So it's like steps in a process.
Yeah, like steps in a process of change.
Okay. And each step is a transformation.
Exactly. Each step represents a specific change
Okay.
that the matter undergoes.
Okay.
And this sequence, it always happens in a specific order.
So it's not random.
It's not random.
It follows a pattern.
It follows a specific pattern, a specific set of rules.
And does it take time?
Yeah, each transformation takes a certain amount of time
Okay.
to unfold.
And they actually picture this sequence
Yeah.
as a line.
It's a continuous line.
Okay.
And they say this line, it's constant.
Like a timeline.
It is like a timeline.
Yeah.
And it's universal.
So it applies to everything.
It applies to all matter in the universe.
Wow.
And they even say that it could be translated into any language.
So it's like a fundamental language of change.
Yeah, that's a great way to put it.
Okay, so this simulator,
Yeah.
it's like a way to map the journey of matter
Exactly.
through all these different states.
Through its various states of being.
And we can use it to understand the past,
Yeah.
the present,
The present and even the potential future.
of how matter might transform.
Yeah, of how it might continue to change.
Okay, so let's go back to subtraction for a second, 'cause I'm
Go.
still kind of hung up on that.
Sure, yeah.
How do we subtract if we can't actually subtract?
Okay, so take their example of 9 minus 1.
Okay, 9 minus 1.
In traditional math, that's 8.
Right.
And it means 1 unit is gone.
Yeah, that
It
makes sense.
ceased to exist.
Okay,
But in Mathematicus Universal,
yeah.
if a state that we call V9 on the simulator
Okay,
transforms into a state called V8,
okay,
it doesn't mean that a unit disappeared.
okay.
It means that a transformation has occurred.
Okay, so something changed.
Yeah, something changed, but nothing vanished.
All right, but how do we understand what that change was?
Okay, so to understand what happened
Yeah.
to that initial one that seems to have been subtracted,
Right.
we essentially rewind the simulator.
Okay.
We go back to the beginning,
To V1.
to V1,
Sure.
and then we count up
To V8.
to V8.
Okay.
So instead of focusing on what's missing,
Yeah.
we're using addition.
Track the change.
Yeah, to track the sequence of events
That led to that new state.
that led to the transformation.
Okay, so it's not about what's gone.
Right.
It's about tracing the steps
Exactly.
that got us here.
It's about understanding the journey.
Okay, and to make sure nothing's really missing
Yeah.
in this mathematical picture.
The source suggests using 3 simulators at the same time.
3 simulators.
Yeah.
Okay.
So one simulator tracks what we have right now,
Okay.
the current state.
All right.
The second simulator details all the changes that have happened.
Like the history of transformations.
Exactly.
Okay.
And the third simulator
Yeah.
represents the final result,
The new state.
the new state of things.
Okay, so by looking at all 3 together,
Yeah.
you get the full picture.
You get the complete picture of the transformation
without anything actually disappearing.
without anything vanishing from the math.
Wow. Okay. That's a lot to take in.
It's a pretty dense
I mean,
concept.
it's pretty cool.
Yeah, it's a really interesting way of thinking about change.
Okay. So we've talked about subtraction.
Yeah, we've tackled that beast.
We've redefined it.
We've redefined it.
What about the other operations, like addition, multiplication, division?
All right, let's start with addition.
Oh, okay.
So in mathematics, universal
Yeah.
addition, or summa,
Summa.
is basically about accumulating the same kind of matter.
Okay.
So they give this formula.
Okay.
Summa 1 plus summa 1 equals summa 2.
So you're adding together units of the same stuff.
Yeah, like adding apples to apples.
Okay.
And this process of adding the same thing to itself
Yeah.
is considered infinite.
It can go on forever.
Yeah, in theory, it can go on forever, but
Oh.
there are limits, and the limits are defined by orbits.
Orbits.
Yeah, the path that matter follows due to gravity.
Okay, so the orbits kind of put boundaries.
Yeah, they define the boundaries of each instance of infinity.
Interesting.
Yeah, and they also say that 0 in this system
Zero,
represents the effect of matter's existence,
which is...
which is its gravity.
Oh, okay, so 0 is like the baseline.
Yeah, like the fundamental starting
But
point
for matter.
for the existence of matter.
Because matter always has gravity.
Right.
Okay, cool. All right, so addition is about accumulation
Mm-hmm.
within the boundaries of orbits.
Yeah.
What about multiplication?
Okay, so multiplication
Yeah.
in mathematics is universal.
Yeah.
It's not really about repeated addition.
Okay, so it's not like 2 times 3 is 2 plus 2 plus 2.
Right. It's not about that.
It's different.
It's more about comparison.
Comparison. Okay.
So, for example,
Yeah.
1 multiplied by 1 equals 1.
Okay.
And they interpret that as comparing a unit of matter
To itself.
to itself to understand its complete cycle.
Like its behavior.
Yeah, its behavior, how it exists.
Okay.
And they also talk about the importance of whether the result is even or odd.
Oh, interesting.
So even results,
Yeah.
like 2 times 2 equals 4.
Okay, 4 is even?
4 is even.
Right.
They say that's associated with finite matter
Finite
matter that has a limit.
Okay.
While odd results,
Yeah.
like 1 times 1 equals 1.
1,
3 times 3 equals 9.
9.
5 times 5 equals 25.
Yeah, all odd.
All odd.
Okay.
They say that indicates a tendency towards infinity
Through their orbit.
through the orbits, yeah.
Okay, so even is finite.
Even is finite.
Odd is infinite.
Odd tends towards infinity
Because of the orbits.
because of the way it moves through space.
Okay, so multiplication is less about
Yeah.
like adding groups together
It's not about repeated addition.
and more about understanding
It's about understanding the nature of the matter itself.
like its inherent properties
Exactly. Its inherent properties and its potential
through this self-comparison
through this self-comparison.
and its cyclical behavior.
Exactly. That's a lot.
It is. It's a lot to wrap your head around.
Yeah. Okay, now what about division?
All right, so division
Yeah.
seems to have a very specific use in Mathematicus Universal.
Okay.
It's mainly used with the number 2.
2.
So they have these formulas like 0 divided by 2 equals 0.
Okay.
1 divided by 2 equals 0e.
0e.
Yeah.
Okay.
2 divided by 2 equals 1.
Okay.
3 divided by 2 equals 1e.
1e.
And so on.
Up to 5.
Up to 5 divided by 2 equals 2e.
2e. Okay.
And they present this as a way to detect imbalances or potential issues in these fundamental pairs of matter,
Okay.
which they represent with the number 1.
So it's like you're dividing these basic units of matter.
Yeah, you're checking to see if they're balanced.
Okay. And the e
The e.
in the results.
Yeah.
What does that mean? They say it suggests an asymmetry
Okay.
or like an incompleteness in the pair.
So it's like a flag
It's a flag.
that something's not quite right.
Yeah, something might be off.
Okay.
And they also say
Yeah.
that the total amount of each type of matter, 1,
Yeah.
comes from this division by 2.
So division is like the source of
Yeah, it's like the
it would
origin
matter.
of the fundamental building blocks.
Okay. So division is not about splitting something in half.
Right. It's not about simple division like we usually think of it.
It's more about...
It's more about identifying these fundamental pairings
Okay.
and checking for imbalances.
Interesting.
Yeah, it's a pretty unique way of using division.
Okay. And they also mention a 5th operation,
Oh, yeah. The summa resta.
summa resta,
Yeah.
which is kind of a weird name
It is a bit strange, right?
because we've already established that you can't really subtract.
Yeah, but remember,
Yeah.
subtraction in mathematics is universal.
Yeah.
It's not about things disappearing.
Right. It's about transformation.
Yeah, it's about transformation.
Okay.
So the summa resta,
Mhm.
it's connected to the idea of life being eternal.
Life being eternal.
Yeah,
Okay.
because since matter never really disappears,
Right. It just changes
this
it.
changes, it
Wait,
transforms.
yeah.
They say this sumeresta,
Yeah.
it represents this continuous cycle of existence.
So it's like a mathematical expression of eternal life.
You could say that, yeah.
Okay, so we've got these 5 operations,
Mm-hmm.
and they all kind of work
They
together
all fit within this framework.
to describe this universe.
Describe this universe where matter is fundamental
Yeah.
and it's constantly transforming
And connected.
and interconnected.
Yeah. Okay, so let's zoom out for a second
Right.
and talk about some of the bigger implications
Yeah, the bigger picture.
of all this.
Okay.
So the source talks about the universe's beginning
Yeah.
as a repeating cycle.
Right. So the universe isn't just a one-time event.
It's like a loop.
It's a cycle that keeps repeating. Yeah. It's a pretty mind-blowing idea.
And they say that gravity and light,
Yeah.
they don't need space.
They don't need space to exist.
What does that even mean?
It means that they're not like things
Like physical things.
that travel through space.
They're more like
They're more like effects
of matter.
of matter existing within space.
Okay.
So matter is the fundamental thing.
Yeah.
And gravity and light are consequences of matter being there.
But their influence extends infinitely.
Yeah, they don't need a medium to travel through.
Okay, so it's like matter creates these ripples
Yeah,
in space-time.
that's a good way to think about it.
And those ripples are gravity and light.
Exactly.
Okay, and matter itself changes.
Yeah.
Through addition.
Through this process of accumulating more of the same stuff.
So it's always building on itself.
Yeah, it's constantly evolving and becoming more complex.
And there's this connection between matter's gravity
Yeah.
and its tendency to repeat.
Right. So once matter exists,
Yeah.
its own gravity kind of ensures
But it'll keep going
that the cycle will continue.
through these transformations.
Exactly.
Okay, and what about energy?
Okay, so the source makes a specific point about energy.
Okay.
They say that energy's main role
Yeah.
is to push matter around.
To exert a force.
Yeah, to exert a force on matter.
Okay, so it's not a fundamental thing.
Right. It's not like matter and gravity.
It's more like a tool.
It's more like a tool that acts on matter.
Okay. And they also say that light doesn't need matter to exist.
Right, which seems a bit contradictory.
Because we just said that light is like a form of gravity,
Yeah, but remember,
which is caused by matter.
we were talking about how light originates from matter,
Right.
but once it exists,
Yeah.
it can travel through space
Without needing more matter.
without needing to be constantly generated by matter.
Okay, so it's like the ripples
Yeah,
keep going,
they keep propagating,
even if the source is gone.
even if the original matter is no longer there.
Okay. All right, that makes sense. Now, what about life?
Okay, so when it comes to life,